Welcome to ThinkViL educational videos. In this video, we will learn about periodic table, covering their theory, key terms and their classifications. Now, what is periodic table? The periodic table is a systematic arrangement of chemical elements based on their atomic number, electron configuration, and chemical properties. Dmitry Mendeleev first developed the periodic table in 1869, and it has been modified over time with the discovery of new elements. The modern periodic table follows the periodic law, which states that the chemical and physical properties of elements repeat periodically when arranged by increasing atomic number. The periodic table is organized into periods and groups. Now, what is periods and groups? Horizontal rows in the periodic table are called periods. There are 7 periods in the periodic table. Each period shows how many electron shells are present in an atom of that element. Vertical columns in the periodic table are called groups or families. There are 18 groups in the periodic table. Elements in the same group have similar valence electron configurations, which means they often exhibit similar chemical properties. Let's understand some key terms in periodic table. The first is element name and symbol. An element name is the official name given to a chemical element in the periodic table. Each element has a unique name. For example, hydrogen and helium. Each element in the periodic table has a unique chemical symbol, which is usually 1 or 2 letters, is called element symbol. For example, hydrogen and oxygen have element symbol H and O. Now, atomic number and mass. The atomic number represents the number of protons in an element's nucleus. For example, hydrogen has atomic number 1, meaning it has 1 proton. Atomic mass. The atomic mass is the weighted average mass of an element's isotopes, measured in atomic mass units, AMU, or unified atomic mass unit, U. For example, the atomic mass of carbon is 12.01 U. The next is electronegativity. The electronegativity is a measure of an atom's ability to attract electrons in a chemical bond. In the periodic table, the electronegativity decreases as we go from top to bottom in a column. It increases as we move from left to right across a period. It is measured on the Pauling scale, ranging from 0.7 to 4.0. Fluorine has the highest electronegativity, 3.98. Metals have lower electronegativity, while nonmetals have higher values. The next is oxidation state or oxidation number. The oxidation state of an element represents the charge it can have when forming compounds. Oxidation states are positive when an atom loses electrons. Oxidation states are negative when an atom gains electrons. Oxidation state can be 0. Some elements can have multiple oxidation states depending on the compound they form. Now, melting and boiling point. Melting point. The melting point of an element is the temperature at which it changes from a solid to a liquid. For example, iron melts at around 1538 degrees Celsius. Boiling point. The boiling point is the temperature at which a liquid element changes into a gas. For example, mercury boils at 357 degrees Celsius. Let's discuss the blockwise classification of the periodic table. The periodic table can be classified into the following blocks. S block. S block have the elements in which the last electron enters the s orbital of the outermost shell. P block. P block have the elements in which the last electron enters the p orbital of the outermost shell. D block. D block have elements in which the last electron enters the d orbital of the penultimate shell or second last shell. F block have elements in which the last electron enters the f orbital of the inner shell, typically placed separately at the bottom of the periodic table. Now, let's classify the periodic table groupwise. Alkali metals. Alkali metals have elements in group 1, except hydrogen, that are highly reactive metals, soft, and have one valence electron. Alkaline earth metals. Alkaline earth metals have elements in group 2, which are reactive metals, less than alkali metals, and have two valence electrons. Transition metals. Transition metals have elements in groups 3 to 12, also known as D-block elements, which form colored compounds and show variable oxidation states. Post-transition metals. Post-transition metals have elements located to the right of the transition metals. They are softer metals with lower melting points and less metallic character. Noble gases. Noble gases have elements in group 18, which are inert gases with full outer electron shells, making them very stable and unreactive. Lanthanoids. Lanthanoids have elements with atomic numbers 57 to 71, part of the F block, known as rare earth metals, and have similar properties. Actinoids. Actinoids have elements with atomic numbers 89 to 103, also part of the F block, and are mostly radioactive. Metalloids. Metalloids have elements that have properties of both metals and nonmetals. They lie along the stair-step line in the periodic table. Other nonmetals. Other nonmetals have elements that are non-conductive, often form covalent bonds, and are found mostly on the right side of the periodic table, excluding noble gases. Now, classify the periodic table state-wise. The first is solid. Elements that exist in the solid state at room temperature, 25 degrees Celsius. Most elements in the periodic table are solids. The second is liquid. Elements that exist in the liquid state at room temperature. Only two elements are liquid at room temperature. Now, the third is gas. Elements that exist in the gaseous state at room temperature. These elements have no fixed shape or volume. Thanks for watching the video. For access more educational resources, visit www.thinkvil.com. And don't forget to like, subscribe, share, and press the bell icon for more updates.